sure in the first chapter there remains two more simple topics, two complete chapters. They are one, the corrosion and transitivity. Corrosion and transitivity. Do you know what is the corrosion? Do you see what is it? Do you see? When they purchase this from a shop, it is a thin, shiny iron sheet. I left it in a damp place for the last 3 months. Yesterday when I took it, the shape was revealed. What was happened to it? It has undergone corrosion and shining surface become tarnished due to the material. The new material, this is the form is called rust. This is the iron sheet turned into rust and almost all the parts are ruined. This process is known as corrosion. So whenever you see a sheet like this, you notice that this is happened due to the process namely or due to the reaction named corrosion. Now we want to know how it happens, how the corrosion taking place. We all know that in the atmosphere there contain oxygen, water vapor, carbon dioxide, nitrogen, hydrogen and air gases, and at the same time a number of polluting gases from the industries. So above all, when these two are for oxygen, water vapor and carbon dioxide is found everywhere in the atmosphere. When we place a thin clear sheet of iron in the air, first it reacts with the oxygen, then it reacts with the water vapor, and finally it reacts with the yeast. Certain metals, not iron, certain other metals react with the carbon dioxide also. For example, the copper, it has also formed a coating of basic copper carbon. Copper, you know, Cu, basically Cu. When copper is exposed to air for some times, the copper reacts with the oxygen, water vapor and carbon dioxide present in the air to form a coating on its surface. Its chemical name is basic copper carbon. It is commonly known as verdigris. Do you know what's the color of verdigris? Green. When copper is exposed to air, the copper metal is exposed to air, it reacts with the substance present there to form a coating. It is known as verdigris. Its chemical name is basic copper carbon. Almost all the metals reacts with the when it is exposed to air, it reacts with the elements or substances present in the air. So then its color, its shiny color disappeared. Then a tarnished color is formed in surface. When we place the magnesium ribbon, we have seen this in this chapter. When magnesium is placed in the flame with a dazzling flame to magnesium oxide, if its surface is cleaned. When magnesium is exposed to air, a coating of magnesium oxide is formed. If we must clean the surface of magnesium ribbon before burning to remove the coating. If we don't remove the coating of magnesium, it does not burn. It acts as a protective layer. Similarly, if you purchase aluminium vessels or aluminium plates, etc. from the shop, when we are purchasing, it has a shiny appearance. It is brought to home and it is used for cooking purpose. After several days, we look at its surface, the shining color disappears and becomes tarnished. Aluminium also reacts with the oxygen present in the air to form aluminium oxide. Here, there is a difference between the corrosion of aluminium and iron. Do you know what is the difference? Aluminium, the coating formed on the aluminium surface is thin and it acts as a protective layer. So, then if the aluminium coating is formed on its surface, then the metal inside is protected. Then its corrosion stops. But at the same time, the iron reacts with the oxygen and atmosphere formed in the air to form hydrated iron oxide. It is known as rust. Hydrated iron oxide is known as rust. It has so many holes in it. So the air again enter into the metals and reacts. The process of rusting continues till the metal ends because the rust formed is thick and so many holes on the surface. So the rusting, the process is corrosion is continuous till the metal ends. It is a great loss to our nation. The bridges, so many buildings, after several years, they have disappeared, so many damages to be brought down due to this process. But at the same time, a question arises. We already, in the first episodes, I studied that metals always donate electrons, gives electrons. So it always reacts with the substances surrounding it. Yet there is another question. Gold, it does not fade its color. Why? No two elements have the identical properties. Gold, it has the least properties. Gold and platinum has least properties. So its tendency to lose electrons or react with oxygen is very less. So it does not fade the color. The silver, on the other ways, silver does not commonly react with the oxygen present in the air. It reacts with the hydrogen sulfide present in the air. So it has a coating of silver sulfide is formed in surface. So after several weeks, the ornaments made by silver are turned black due to the formation of silver sulfide on its surface. Silver, the metal silver reacts with the hydrogen sulfide to form silver sulfide on its surface. So the color of silver is fade. You can you test your ornaments, how its color are made of silver, how it changes. So this is corrosion. Corrosion means any metal when exposed to air reacts with the oxygen, carbon dioxide and water present there to form a compound on surface, and continuously it ends and continuously it is ends its and form a new substance. This process is known as corrosion. The rusting of corrosion can be denoted by the chemical reaction taking place is 4Ap plus 3O2 gives plus XH2 to form 2Ap2O3 This is known as rust. You already heard that the Taj Mahal also is fading its color. Why? Due to the sulfur dioxide from the nearest industries. The nearest industry produces sulfur dioxide and is brought to the atmosphere. The marble. You already know that Taj Mahal is made of marble. This marble reacts with the sulfur dioxide present in the atmosphere and gradually its color changes. This is also another type of corrosion. The metal is not included. Though the metal is not included, this process are all known as corrosion. The next term is density. The correct pronunciation is density. Particularly density it is also a like corrosion. It is a familiar term in your home. The oils and fats present in the food materials when kept in air for some time, it is spoiled. It deteriorates and bad smell, bad taste, a bad odor is produced. That process is known as density. We order the jam, the bread jam. We kept in air for 2 or 3 days. For the next day, we get a bad smell. Butter, if we kept in open air for 2 or 3 days, and oxidation takes place, and a bad smell is produced. At bad taste, we cannot eat all. The taste is also changed. That also, the oxidation of fats and oils present in food materials undergo changes, and a bad smell or color and taste is and odor is produced. That process is known as density. For you know, all of you know that chutney. If you get to something after 1 or 2 days, it is spoiled. In Malayalam, we say that kanichu poi. Chamdi kanichu poi. Similarly, there are such food products which contain more fats and oils, which undergo oxidation and its color, odor and smell are changed. That process is known as density. This can be prevented by, how we can prevent it? This can be prevented by antioxidants. You already know that in pickles, it also undergo rancification. How we can prevent it? We add vinegar. Vinegar is known as an antioxidant. Vinegar is an antioxidant. Similarly, we all know that the packing is of lace. The packing is lace, it has crushed. How it crushed? When we open the packing cases, there are 10 or 20 pieces, but we are not seeing it's a big packet. What are the businesses to do? These chips packets are filled with nitrogen gas. What is the purpose? You know that nitrogen is an inert gas. Nitrogen is an inert gas means it does not, the reactivity of nitrogen is very less. The oxygen air is removed from the packets and it is filled with nitrogen. So it is very inactive and it kept for a long time. So the chips packets are flushed with the nitrogen. So we can prevent it. So several other techniques have been done in our kitchen. You know, you ask your mother how we can prevent this, how we prevent this rancification. So today you must know what is density and how we can prevent it and what we mean by antioxidants. Similarly, in the case of corrosion, today you look at your gate. Which material the gate is made of? Almost all the gates of our homes are made of iron. You carefully look at. In certain it is painted with the different colors, white, yellow, red, black. In certain places of the border, there we can see there is rust on certain ends. And what happens is where there is no paint. So how we can prevent corrosion? By apply paint to one surface. What is the principle involved in it? We already studied corrosion takes place when a metal is exposed to air. So the principle involved in the painting is first attraction, second what do you know? Prevention from the contact with air. If we painted the material neatly and clearly, the metal inside does not contact with the air outside, so corrosion can be prevented. So the principle principle involved is prevent the metal contacting from the air. If it is contact with the air, metal reacts with these materials, this substance present in here and undergo corrosion. So the principle is prevent you contact between the air and the metal. So we paint our gates and grills, etc. Now the first chapter of textbook chemistry is almost over. Now we get an idea about corrosion and lancidity. Lancidity means the spoilage of food materials which contains fats and oils. Fats and oils, which are due to the oxidation fats and oils, is color, texture and disappears and body smell appears. That process known as lancidity. You have, I think, as you have got a clear idea about a chemical reaction. Only one thing you have to face difficulty is, I think, to write the chemical formula. In the first session also I said to you that for writing a chemical formula you must know two things. One, the elements atomicity. Elements atomicity. Compounds valency. So you must have a clear idea about writing a chemical formula. In the law, in the standard 9 writing molecule formula, in page 37 of your standard 9 test, there is the formula, radicals and their valences are also given. You go through that passage and try to write the chemical formula of such compound. Especially, you please note here, what do you mean by radicals? Radicals are a group of atoms having a charge. Radicals are a group of atoms having a charge. Some common radicals that come in this chapter or in the high school session was 1. Hydroxide, OH, nitrate, carbonate, sulfate. These radicals and their valences are, you must learn by heart. If you forget this, you must remember that nitrate comes from nitric acid, HNO3. If nitrate radical, the valence nitrate radical is 1, CO3. Carbonate radicals come from H2CO3, carbonic acid. Its valence is 2, and the sulfate, the valence is also 2. It comes from sulfuric acid. These common. These are there is also chloride radicals. Chloride is not called a radical, it is an ion. Atoms are electrically neutral. Charged atoms are called ions. Chloride comes from HCl. So its valence is also 1. It's not a radical. Radical means a group of atoms have a charge. Then some metals or some elements. By studying the periodic table, you understand the position of the elements. We can, if we know the position of the elements, we can predict its valency. The group 1 elements valence is 1, group 2 valence is 2, group 13 valence is 3, group 14 valence is 4, 15 valence is again 3, 16 2, 17 1, 18 valence. So when we are going to study the period table, we can get a clear idea about the valency of the elements. In between group 2 and 3, group 2 and 13, there is a group, what's their transition elements. They are here transition metals. these transition metals, especially lead, zinc, silver, iron, copper. You must please learn the valencies of these metals. If you know the valencies of these metals and the valencies of the radicals, you must be able to write the chemical formula of some common substance in your surroundings, in your lab, in your textbook. The valency of silver is 1, that of lead is 2, zinc is 2, iron has 2 valency. In ferrous compounds it is plus 2, positive 2, in ferric compounds it is positive 3. Similarly, copper has 2 valencies. In cuprous sounds it has positive 1 valency, cupric sounds it has positive 2. So, these must be keep in your mind the valencies of these transition elements. Then only you can write the compounds of the ordinary compounds in your textbook. If you write the chemical name, the chemical formula of the compounds correctly, you can easily balance the equation. So you are familiar with these balances of transition elements. The balances of other elements can be easily find out from the periodic table. So by several usage, you can by heart the balance of this. Silver valence 1. Lead is the valency 2. You must be careful about iron. Iron has 2 valencies. Iron has 2 compounds. Iron is a transition element. The common property of a transition metal is it shows, some of the metal shows variable valency, whereas and very. Similarly, copper is another transition element. It also shows variable valency. Cuprous sounds positive 1. Sounds positive. There is in iron, for example, ferrous oxide Fu. The valency of in ferrous compounds, the valency of iron is 2. The valency of oxide is 2. When the compound is formed, they interchange and return on the subscripts of the. Therefore, it becomes Fe2O2. If the valencies are same, we don't write it. And same is in ferric compound. The valency of iron is 3, or that of oxygen is 2. So, when the compound is formed, Fe2O3. So, you must be careful writing the compound, some chemical formula of this compound. This is not given in your textbook. Yet, if you score 10% marks, you must be study this. The valence. Then we can write the formula of chemical formula of any compounds. For example, ferrous sulfate, FeSO4. Why? The valency of sulfate is 2, ferrous compounds valency of iron is 2. But in case of ferric sulfate, Fe2SO4 thrice. But how it comes? Like this shows us iron has 2 valencies, ferrous and ferric. Similarly, copper also. Then, if you study this, the balancing chemical equation becomes easy. In this chapter, you ask number of chemical equations and reactions. In step by step, not Monday, never say we can study it carefully. Then the first session onwards, we can have an overall look in a chemical reaction. What happens? We write a chemical reaction. 2PbO plus C gives 2Pb plus CO2. Use a reaction. First you have to note down in a chemical reaction there are some changes take place. A chemical equation represents a chemical reaction. Then we have studied what you have learned in this chapter. Can apply this in every equation. What are the changes take place? First, you look at the reactants, products. Then you look at whether it is balanced or not balanced. Thereby, I can one thing to say: in balanced or unbalanced reaction, I said to you always you use table method. In Malayalam, there is a particular Valayathil Kudi Chadi Tivanam, Valayilla Chana. Valayathil Kudi Chadi Tivanam. About first, you must be till you become an expert balancing chemical, you use the table method. In table method, you write 3 columns. The first column name of the element, second column number of atoms react side, third column number of the elements in the product side. Then you can balance and get a conclusion. Then second you have to note whether it is a balanced or now it is a balanced chemical reaction. The other thing is what type of reaction is. You have to know that there is 2 reactant, here also 2 reactant. Hence it is not a combination, not a decomposition. The third is when the carbon displaces oxygen. So it is a displacement reaction. The other thing is there is a change in state, when a reaction takes place, change in state, change in color, change in temperature and evolution of a gas, etc. Here on this reaction, this carbon dioxide is involved. If a gas is involved, it is short not on this aroma molecules. So the carbon dioxide gas is in this reaction, there is gas is involved. So when you observe a reaction, what you have studied in this chapter will apply. You will look at the reaction and ask these questions. Then the other thing is whether it is oxidation reaction. Which substance is oxidized, which substance is reduced. The last episode we studied that oxidation means addition of oxygen. Reduction means removal of oxygen. Oxidation means addition, combination with oxygen. In the case of oxidation redox reactions, you may please note that, never forget it, you don't these 2 reactants. If a reaction takes place, there must be at least 2 reactants. You must look at these 2 reactants. At first don't look at the products. Here, lead monoxide and carbon. What happens? Which level combines with oxygen? But first look, we have seen that carbon, which is oxygen removed, lead oxide is carbon removed, and oxygen carbon combines with oxygen. So the substance oxidized is carbon, the reduced is called the lead monoxide, not lead. The substance oxidized carbon, the substance reduced lead monoxide. Not go to the right side for writing that. For writing the answer, we can go to the right side, but not write in the answer sheet. Then there are some general questions. There are what are exothermic reactions, what are endothermic reactions. From the word itself says the definition. Exothermic, excess. Any type of energy, especially heat, is liberated. Endothermic reactions. One is exothermic, the other is endothermic. Then in the endothermic reaction, there are 3 types. Where heat energy is absorbed, or light energy is absorbed, or electrical energy is absorbed. You may find out examples for each type of reaction. Heat energy is absorbed and undergo decomposition. Calcium carbonate when heating decomposes to calcium oxide and carbon dioxide. Electrical energy is absorbed is hydrolysis of water. Hydrolysis of water, the picture is given in your textbook. Take a plastic mug, both balls on the outside and 2 electrodes are fitted, and when electricity passes through water, On one test tube, hydrogen is collected and the other test tube, oxygen is collected. There, the water, acidified water, absorbs electrical energy and it decomposes, where electrical energy is absorbed. Then there is another experience given in your textbook where light energy is absorbed. That experienced silver compounds. When silver compounds exposed to sunlight, silver chloride is exposed to sunlight, its color changes to grey and chlorine gas is evolved and grey silver metal is appeared. Then silver bromide is exposed to sunlight, bromine is exposed and grey silver is also produced. This principle, the substance which is coated on the film, the X-ray film, photographic film is silver bromide. Silver bromide. You must remember these materials. So, similarly, some chemical names also we use there. The calcium carbonate on heating decomposes to calcium oxide and carbon dioxide. It is a calcium carbonate on heating. Calcium carbonate plus heat gives calcium oxide and carbon dioxide. This is an endothermic reaction. This calcium oxide, taken in a beaker and adds of water, it changes to calcium hydroxide. Calcium oxide, one reaction water into calcium hydroxide plus heat. You are taking glass, I was showing you that some calcium oxide is taken in a beaker and add some water. When place the can outside, we fill a heat. So, the chemical name of calcium oxide is lime. The chemical name of calcium hydroxide is slated lime. You have to study this chemical industrial name. The industrial chemical name is calcium oxide. Industrial name is lime. The chemical name is calcium hydroxide. Industrial name is slated lime. This may be because of the questions. So these points must be also remembered. This calcium oxide is used for cement production. So the industrial names of lime and slacker. Lime is also known as Uclane. It is also called Uclane. Lime and Uclane are same. Or some patient has read discussion between Uclane and slacker. Uclane is calcium oxide, slacker lime is calcium hydroxide. The substance used for whitewashing is the slacker lime. After whitewashing some days, is calcium oxide into carbon dioxide. Okay, calcium hydroxide into calcium carbon dioxide. How this calcium hydroxide, when exposed to air, it reacts with the carbon dioxide present in the atmosphere. Now calcium. Now it is not calcium hydroxide. Now it is calcium carbonate. So we get a shiny appearance. So the industrial names also you must remember. Then you must take each reaction one by one and then the exercise. We can do the exercise. You first read the lessons completely and try to answer it. If there is any mistake, this answer we can discuss the answer and then the answer should be sent to you in WhatsApp. A short notes also be given in here. The first question is, which of the following statements about the reaction below are incorrect? 2PbO, solid state, reacts with carbon, 2Pb plus CO2. Question is, which of the statements about the reaction below are incorrect? 4 സ്റ്റേറ്റ്മെന്റ് കൊടുത്തിട്ടാണ് ഇൻകറക്റ്റ് ആയിട്ടുള്ള കറക്റ്റ് സ്റ്റേറ്റ്മെന്റ് എന്ന് അറിയുന്നത്. ഫസ്റ്റ് ഇൻ കെമിസ്ട്രി യു മസ്റ്റ് റീഡ് ദ ക്വസ്റ്റ്യൻസ് കെയർഫുള്ളി. Then second is answer to the point. Answer to the question. Don't in science subjects, especially maths, physics, chemistry, biology, etc. Don't a detailed answer is required from you. Fully to the points. Or incorrect. The correct answer is pure substance oxidized. Carbon is oxidized. Carbon is oxidized. Lead oxide is reduced. Carbon is oxidized. Lead oxide is reduced. This is correct answer. Other answers are wrong. We can read it here. The first statement. Lead is getting reduced. Lead is. I have already said that you never go to the product side. The oxidized and reduced substances are on the reactant side. So you can read it. In the lead is getting reduced. You never read that. It's a wrong statement. No doubt. Second is carbon dioxide is getting oxidized. That is also a product. Carbon dioxide is oxidized. In the case of oxidation of reduction reaction, we never go to the product side. The oxidized substance and the reduced substance are always in the reaction. Well, we know that these two statements I read are now incorrect. The question is also that which of the border states is correct. We can go to the other. Carbon is getting oxidized. Carbon is getting oxidized. What's the answer? Oxidation is also combination of oxygen. Carbon combines to oxygen. So carbon is a correct statement. Other statement is lead oxide is getting reduced. Lead oxide is reduced. This is also correct. The last two statements are correct. What is the answer? Which of the following statements of the reaction is incorrect? The first two incorrect statements are A and B. That what are they? Lead is getting reduced and carbon is getting oxidized. And the second question is Fe2O3 plus 2Al gives Al2O3 plus 2Fe. Again reduction Fe2O3 now I let you that Fe2O3 what is the meaning? Ferric oxide. Iron is a transition metal. It has two valency, ferrous and ferric. Ferrous converts valencies to ferric converts valencies to. It is now it is not here that you must study it. Ferric oxide reacts with aluminium to form aluminium oxide and the above reaction is an example of a dash. The above reaction we have already studied out 5 types of reaction. What are they? Combination, decomposition, displacement and double displacement and redox reactions. Whether this is a combination reaction, we know that in a combination reaction, two reactors only have one product. So this is not a combination reaction because two products. Whether this is a decomposition reaction, we know that in a decomposition reaction there is one reactant. There is here two reactants. So this is not a decomposition reaction. There is whether it is a displacement reaction. We know that in displacement reaction, the more active element displaces, the less active element makes solution. There we know there the aluminium displaces oxygen to form aluminium oxide and iron getting free. So what type of reaction is the other fourth type reaction is what? Double displacement. There two atoms or two elements exchange their ions each other. Here only only two reactors does not have the ions. The iron has the ion, aluminium does not. So this is an example of what a reaction displacement reaction. The third question is what are when dilute hydrochloric acid is added to iron pellets? Pick the correct answer. Iron pellets means iron powder. When added to 2HCl. What are the products? AgCl2 plus H2. What happens? You have a general idea. Any metal reacts with the acids. Order they produce is salt and hydrogen. Any metal. If it is reacting with the acids, it produces hydrogen and salt. Iron, magnesium, zinc, or any metal. Zinc iron reacts with sulfuric acid, iron sulfate and hydrogen. Magnesium reacts with the hydrochloric acid, magnesium chloride and hydrogen. Zinc reacts with the hydrochloric acid, zinc chloride and hydrogen. Or any metal reacts with the acids to produce hydrogen and its source. It's a general concept. So you are no doubt. What happens when dilute hydrochloric acid is added to iron pellets? Iron and hydrochloric acid. When you get the question, you must have applied hydrochloric acid iron. Any iron reacts with hydrogen and its salt. When the hydrochloric acid is used, its salt is sulfur. Is sulfuric acid is used, sulfur. So the answer is what? When dilute hydrochloric is added to iron pellets, hydrogen gas and iron chloride are produced. So the correct answer is hydrogen gas and iron chloride are produced. That is the answer. The other question is, what is a balanced chemical equation? Why should a chemical equation be balanced? I have repeated this. What is a balanced equation? The number of each atoms on the reaction side and the products are equal. It is said to be a balanced equation. Or the number of each atoms on both sides are equal. But even if both sides, one side is reaction side and the other side is product side. The number of atoms in each atom. Here there is only one iron atom. Here only one iron atom. Here two hydrogen atom, two hydrogen atom, two chlorine atom, two. It is a balanced equation. Why? The number of each atoms on both sides with the reactant side are equal. So it is said to be balanced. Why should the equation be balanced? According to law of conservation of mass. What is law of conservation of mass says? Matter can be neither created nor destroyed. If this the number of atoms taking part is mass of the atoms taking part reaction must be always equal to the mass of the correspondent. So according to the reason is that according to the law of mass action, according to the law of conservation of mass, according to the law of conservation of mass, matter can be neither created nor destroyed. And the question, translate the following statements into chemical equations and balance them. Hydrogen gas combines with nitrogen to form ammonia. Hydrogen gas combines with nitrogen to form ammonia. Question is, translate the following statements into chemical equations. The statement is hydrogen gas combines with the nitrogen to form. You can take this one and read the statements. Hydrogen gas combines with the nitrogen. First we have to write the skeletal equation. Then only you can try to balance equation. Hydrogen gas combines with nitrogen to form ammonia. This is skeletal equation. You have to write the chemical equation. Then the second thing is, then you try to balance equation. Here there is three hydrogen atom. If three hydrogen atoms get, we have to note 3 here. For if we get to 2, it's only one hydrogen atom, one molecule, 2 hydrogen atom. That is 2 hydrogen atom 4. Therefore, we cannot get 3. Therefore, we get 3, that is 6 hydrogen atom. If 6 hydrogen is here, we also 6 hydrogen there. If 6 minus say what happen? There is 2 item. But this 2 item here also do. This is now it is balance equation. And 3H2 plus H2 gives you anything. You try and check it. Before writing, you can check it again. Similarly, the other equation is hydrogen sulfide gas bears in air to give water and sulfur dioxide. Hydrogen sulfide gas. You first write the scheduled equation. Hydrogen sulfide gas, H2S, bears in air. Air means oxygen. The only substance, the only helping burning is oxygen. To form sulfur dioxide and water. You have completed the first session. As you write, the stateability is correct to chemical equation. The stateability given is written as the chemical equation. This is chemical equation. The second step is balance equation. How to balance equation? You have to use the table method. 2H2S, after using the we get the 2H2S plus 3O2 gives 2SO2 plus 2H2O. You have to try to answer the next question yourself. If you find any difficulty, that should be given the coming days. You have to verify it, and you any doubt you can do it. You repeat it and write the answer. A brief note of this chapter is also given to you as well. You first you read the textbook several times, then you read the brief note given to you, then answer all the questions. Then we can score full marks in chemistry in this academic year. Okay, thank you. We can do the other questions in the coming classes.